Well, hello once again. Welcome to the Waters and Stanton video channel. I'm out for a short walk in Hockley Woods before having a look at an antenna that I've been asked to do a review on. It's a portable antenna actually, and it unusually covers all the bands from 6 meters to 160 meters. Now, that was the first band I operated on, 160 meters, many years ago, and I remember using an old tank whip and a loading coil wound on a bit of wooden dowel and having no idea what frequency it was tuned to. The only way I actually resonated it was by adjusting the number of turns on the coil and the length of the whip until the coil was very sensitive to hand capacity, and that's the measure I had of whether or not I was near resonance. Didn't have a VSWR meter. No, in those days VSWR meters were very rare and only for the rich. But 160 meters was a popular band. And the only reason I mention this is because, as I say, 160 meters is a band that's not generally covered by a lot of antennas.
Welcome to the Waters and Stanton Ham radio channel, presented by Peter Waters.
The antenna we're going to look at is the SPX500. It's a mobile antenna that covers 160 meters through to 6 meters, and it's very compact. I would perhaps describe it more as portable or static mobile antenna, because I don't think that the top telescopic whip would be strong enough to travel down a motorway at 70 miles an hour. But it's got some interesting possibilities and a few tricks, so let's take a look at it. It's interesting to consider portable operation with a mobile installation, and it has a tendency to be quite efficient. The reason is that although you've got a short whip antenna, which normally would have a very low impedance and very low efficiency, you're mating it up to the car body. Now, the car body acts as a sort of a counterpoise, but it does radiate. The car body is totally isolated, courtesy of the rubber tyres and so forth. So the car body actually radiates. That tends to make the whole system more efficient, which explains why you tend to get a better match than you'd imagine, because the impedance of a short mobile antenna can be just single figure ohms, and you'd expect to get pretty high VSWR. Well, in practice you don't. I think if you're going to go outside for portable operation, you should consider using perhaps a mobile setup. Give it a try, because it is remarkably efficient. Now, this antenna is very compact, and it means to say that you could sort of slip it in the glove box of a car, but nevertheless it is also very efficient because it's got a long whip, and as I say, it's working against the car body. So let's have a look at what you get in the package and see what sort of results you get. Well, this is the kit of parts you get with the SP500X, and I'll run through the pieces to explain how it all fits together. The heart of the unit is the base coil, and that is around about 12 inches long, and you'll see that it's got tapping points up and down it. And at the input end, we've got a PL259 fitting, so that goes onto a standard SO239 mobile fitting for your car. And at the far end, we've got a thread there, and that thread accepts the telescopic whip, which I'll now show you. Now, the chrome whip really impressed me actually. It's nicely made. You've got a socket at the bottom which screws onto the top of the base loading coil. Got a protective piece at the end, and it telescopes into 12 sections, which extends just over 7 foot long. So that helps to make the antenna pretty efficient. Assembly just requires the whip to be screwed onto the base section. That means to say that once the antenna is assembled, and if it's pulled out, extended to its maximum length, the total length of the antenna is 8 foot, and that should make a pretty efficient portable antenna. Band selection is achieved by this short-in cable with many plugs on each end, and you plug each end into the appropriate sockets on the base whip in order to switch bands. In this configuration, without the shorting cable, the antenna resonates on the 80-meter band, with one end of the cable plugged into the bottom and the other end plugged into the first socket. That shorts out the first section of the coil, and the antenna resonates on the 40-meter band. Now, this antenna also covers the 160-meter band, and that's achieved by adding an extra coil on, which is also approximately 12 inches long. So on 160 meters, the total length of the antenna could be something like 9 feet. Quite impressive. Also included in the kit is this solder tag, which would fit between the base of the antenna and the mount. It may be designed for adding a radial, but it's not mentioned in the instructions. The instructions, by the way, give you good starting points for the adjustment of the top whip section. And when it's packed down, you can see how this 160 meter to 6 meter portable telescopic antenna is so small it would fit in your pocket. Here's some VSWR measurements I got. Bear in mind the antenna is mounted on the rear door of the van, but the van itself roof is fiberglass. So I was very impressed with this. It's almost a perfect match on 20 meters. 40 meters was equally impressive, and a bandwidth here of about 100 kilohertz at the 2:1 VSWR point. Now on 80 meters, the VSWR is pretty respectable. It's well below 2:1, bearing in mind that I haven't got any metal roof on the van, so I was quite impressed with that. Now, with a bit of experimentation, which I'll come to in a minute, I managed to get the VSWR on 80 meters even lower. This I was really impressed with. Finally, we come to 160 meters. This is not bad. 2:1 on a very short whip is not bad. I think if I had more metal work on the roof, I'd have got that lower. And also with a bit of fiddling about, which again I'll come to, I think I might have been able to get that lower. But anyway, I was happy with 2:1 on 160 meters. But even with a 2:1 VSWR on 160 meters, it's neither here nor there.
The interesting thing about this antenna is that you can do a very neat trick with it. Because it uses a loading coil at the base, which has got various points at which you can plug in the lead to short circuit it so it raises the frequency, or you move it down so it lowers the frequency, you get more inductance. If, for example, let me give you an example. On 80 meters, you don't need any connection at all with that shorting bar. It's just you use the antenna as it is, and it will resonate on the 80 meter band. But I found that the whip was a bit short on 80 meters. Now, as a good rule of thumb guide, you want an antenna with a long whip, as long as possible. But of course, as you lengthen the whip, so you lower the frequency. So if you're operating on 80 meters and you've got, I don't know, you've perhaps got 75% of the whip extended, it would be nice to actually extend it a bit more to get greater efficiency. Well, with this arrangement, you can, because what you can do is you can short together part of the coil further up. If you plug that short-in lead into one point fairly high up, and then another point a little bit lower than that, the next point down, or the next 2 points down, what you do is you short circuit part of the coil. And if you short circuit part of the coil, it means to say that you've got to counteract that by lengthening the whip. And that's ideal, because the longer the whip, the more efficient it is. And the same applies to 160 meters. On 160 meters, the instructions say, don't use the short-in lead at all, put in the extra 160 meter loading coil at the base, and then extend the whip and establish resonance. Well, you can do that, but again, you find the whip is a bit short. So what I recommend you do is, and I can't give you the exact measurements because it depends on the vehicle, car to car, the points of resonance will change a bit. But what I suggest you do is you short out part of the coil further up and then extend the whip to bring it back to resonance. And what you'll end up then with is a much more efficient mobile antenna. And I think that's a neat trick with this particular antenna, this particular layout. is that you can juggle around with the amount of inductance you get at the base in order to establish resonance. Basically, what you want is the smaller inductance as possible and the longest whip as possible.
Here's the hatch mount that I use, and it's worth taking it off occasionally, cleaning it, make sure you've got a good DC connection. And if you look underneath, you'll see where the 4 screws pierce the paintwork slightly to get a DC connection to the chassis.
I did test it out using my FTX1 field, and it worked very well. I had some CW contacts on the higher bands. On 20 metres, I tried FT8 and I got a good report, no problem at all. I'll just show you a clip here of an FT8 QSR I had on 20 metres with the FTX1 field. So I think it's a very capable antenna actually. It's got a lot of possibility, and provided that you don't drive down the motorway at sort of 70 miles an hour and expect it to survive, it's got great possibilities for portable operation using a mobile setup. And of course, with transceivers like the FTX1 field and the IC705 that don't have antenna matching units built in, it doesn't really matter. You get a good match anyway, and you don't need an ATU, so the whole thing becomes pretty efficient. So there we are. It's a nice little antenna, and little is the word because it is very small, but it's got great possibilities, and that's in stock at our store now. Anyway, as usual, thank you for watching this video. Thank you for your support on this channel. It's much appreciated. You take care. Look forward to seeing you in the next video. Bye for now.